Hey guys, so you guys have a test tomorrow, so I want to make sure I took a moment and went over this review with you, okay? So, number one, suppose that x and y vary inversely. Ooh, that's an important word. Inversely. To have inverse variation, guys, if two things are inversely varied, what that means is that y equals k over x. Now, you should remember that k is called our constant of variation. So when we have y equals k over x, what that means is that it looks like this, okay? And it says an x equals 6 when y equals 3. That's really important information that we're going to come back to, okay? Write the function that models the inverse variation. Okay, this is the model. This is what you want to write. The problem is that you want y and x to be your only variables. You want to know what k is, all right? So what you do is you take this example they gave you and you plug it in. So what I mean by that, guys, is we can solve for k. Because we know that when x is 6, y is 3. So we can say 3 equals k over 6. And now I can solve for k. So it's k divided by 6, so I have to multiply by 6 to get k by itself. 6 times 3 is 18. So 18 is equal to k. So then we know that the inverse variation that models this situation is y equals 18 over x. Okay? So we know that is our answer. Okay? Let's go to number 2. Number 2 is an extremely similar problem. Suppose that y varies directly with x and inversely with z. Okay, let's start here. Y is varying directly with x. Well, this is directly with x, so it'd be y equals kx. Okay, that's what direct variation looks like. It looks like the constant of variation times x, divided by the inverse part, which would be z. Okay, so once again, this is our model, but we actually want to have a number for k. And look here, they've given us y equals 4 when x equals 5 and z equals 10. Since I know these three variables, I can plug it in and the only variable I have left is k. So I can say 10 is equal to k times 5 divide, I'm sorry, what did I put 10 here? I didn't mean to put 10 here, guys. My apologies. It's not z. Oops. Stop! It's not z is 10. I apologize. I'm sorry. It's z is 10. Y is 4. Okay? So 4 equals k times 5 over 10. So I need to solve for k. So I'm going to first get rid of this divide by 10 by multiplying by 10 on both sides. So that's going to give me 40 is equal to k times 5, which I'm just going to write as 5k. And then 5k is 5 times k, so to get k by itself, I divide by 5. So I know that 8 is equal to k. So then I know the model of the situation is y equals 8 times x divided by z. And now the question is then find y when x equals 3 and z equals 4. So I don't know what y is, so I leave y as y, and I say 8 times 3 divided by 4. Well, 8 times 3 is 24. 24 divided by 4 is 6. So y equals 6. So that is my answer. Okay? Next problem. It says, graph y equals 1 over x plus 3. Give the domain and range interval notation. Okay, I'm going to open this up so I have a little more space. Y equals 1 over x plus 3. Okay, so hopefully you guys are like, oh, that kind of looks like a rational function. And I know that rational functions have both a horizontal asymptote and a vertical asymptote. Okay? Now, assuming this was just 1 over x, my horizontal asymptote would be at y equals 0, and my vertical asymptote would be at x equals 0. Okay? So, let's remember how horizontal asymptotes are found. Horizontal asymptotes are found by looking at the degree of the numerator versus the degree of the denominator. Okay? The degree of the numerator for our new equation, so this is what we had, this is our new equation. Well, there's still just a 1 up here. So there's no x, so the degree is 0. Okay, so the degree of the numerator is 0. I'm going to put that in red right here. Okay, now let's look at the denominator, x plus 3. Well, I have an x, and it's being understood being raised to the 1 power, so that's a degree of 1. Okay, since 1 is bigger than 0, I say this is bottom heavy. When something is bottom heavy, the horizontal asymptote is y equals 0. Okay? To get your vertical asymptote, you set your denominator equal to 0. That is something I would write down on my note card for the test. You set your denominator equal to 0. Okay, so x plus 3 equals 0. Now we got to solve for x. So we subtract 3, so x equals negative 3. So my denominator is x equals negative 3. With these two pieces of information, in my opinion, you are ready to graph. Okay? So let's look at what this graph would look like. All right. So remember, we have a horizontal asymptote at y equals 0. So that's just a dashed line across where y equals 0. We all know my handwriting is terrible. Okay? So y equals 0. And then with my vertical asymptote, I know that that's at x equals negative 3, so I need to go back 3. Okay? So there's that. So that's my vertical asymptote at x equals negative 3. And then I just draw the rest, which, assuming there are no reflections, it's in top right and bottom left. Now, the rest of this question said, what is the domain and range? Well, guys, remember, domain is x values that you look at from left to right. So, what is my most left x value happening on these red graphs? Well, this arrow pointing to the left means negative infinity. Okay, so then what you want to do is you want to start at that arrow, and you want to go all the way to the right for this arrow. Oh, it's going to hit this asymptote, right. Is it ever going to cross this asymptote? No. So the most right that piece is ever going to go is an x value of negative 3. That's the most right it's ever going to go. Now, let me ask you this question. Is that all of the graph? No, there's this piece of the graph too. So what is the most left x value of this piece of the graph? Negative 3. Then I want to follow this guy as far out to the right as I can. Well, it's got an arrow pointing to the right forever, so that would mean positive infinity. And your range is very, very similar, except range, instead of being x values, is y values. It's from bottom to top. So when you look at this, you would say, okay, my most bottom y value is happening right there, pointing down. So that'd be negative infinity. 2, okay, follow this guy. What's the highest y value gets to? Well, it tapers off here at my horizontal asymptote of 0. And then I have to pick it up on the other piece, which goes from 0 to infinity. Okay, and boom, that's your domain and range. All right, next question. All right, our next question says, what is the value of x that is not included in the domain of the function y equals x minus 10, y? Look, think about this. This is a fraction. What can I not have in a fraction? I cannot have a denominator of 0. Very good. 1 over 0 would cause a problem, okay? What x value would cause a denominator of 0? Well, I can find that by setting my x value equal to 0. So I add 10. So in other words, x cannot equal 10. A value of 10 is not included in the domain. Because if I was to plug in a 10, I would get a 0 in the denominator, which I cannot have. Okay? Let's move on. Question number 5. Write an equation for the translation of y equals 2 over x that has asymptotes of 3 and 5. Guys, this is x equals 3. This is your vertical asymptote. This is y equals 5. This is your horizontal asymptote. Okay, so first off, vertical asymptotes are found by setting the denominator equal to 0. So if I had to set something equal to 0, and then after I solve it, I get x equals 3, what would this side need to be so that after I solved it, it got me this? X minus 3, that's right. Take a moment. If you were to solve x minus 3 for x, would you get x equals 3? Yes. So instead of having just x in the denominator now, you want to have 2 over x minus 3. Now, I know that we've been talking about the degrees for horizontal asymptotes, and that's very true, okay? But there's a very simple way to write an equation so that it shows that I go up 5, because I'm going from y equaling 0 to y equaling 5. Remember, this is a horizontal asymptote, so it runs left to right. So if I add 5, well, that'll move it up 5, won't it? So that would be your new equation, okay? All right, number 6, guys, is the same thing as number 5, just in graph form, okay? Y equals 1 over x. Well, here's my new equation. Y equals 1 over x. Okay, so where's my new vertical asymptote? It's at x equals 3. Okay, well, how do I get x equals 3 if I set my denominator equal to 0? I get x minus 3. All right, and how do I go from being y equals 0 right here across the x-axis to being at y equals negative 2? I go down 2. Bam. There you go. Okay, let's move on. Number 7. Ooh, I did not take a good picture of this. My apologies. It says it wants us to graph, find the horizontal asymptote and the vertical asymptote. You actually do not have to worry about 10 through 12. It's not necessary. Okay? So, first thing, I don't like to graph first. Okay? I know we put that first. I like to graph last. Okay? That's my suggestion to you. Graph last. All right. So when you look at this right here, I'm going to do number 8 first. The horizontal asymptote is. Remember, this guy doesn't have any pluses or minus some number out here. So I can't just say, oh, it went up 5, it went down 3. But since there's a whole lot of stuff going on, what I probably need to do is compare the degree of the numerator to the degree of the denominator. Okay? The degree of the numerator is 2. The degree of the denominator is 2. That means they are balanced, which means it's leading coefficient divided by leading coefficient. Leading coefficient is simply the number multiplying to the x squared. So what is the number multiplying to x squared here? It's a 1. What is the number multiplying to x squared here? It's a 1. So the horizontal asymptote is simply y equals 1 over 1, which is just what? That's right, 1. Okay? The vertical asymptote. Okay, you find a vertical asymptote by setting your denominator equal to 0. Here's the problem. Look at my denominator right now. How do I set that equal to 0? Hopefully, one of your first thoughts was factor. Okay? But you should also remember that I can also factor out the top in case there's something I can cancel out. Alright, now for the sake of time, hopefully you kind of know how to factor. I can tell you the top becomes x minus 1 times x minus 3. And the denominator becomes x minus 2 times x minus 3. Okay? And now hopefully you're like, oh, Miss Netherland, we can cancel out the x minus 3's. So that leaves me with just x minus 1 over x minus 2. Okay, so I still need to find my vertical asymptote. How do I find my vertical asymptote? I set my remaining denominator equal to 0. So x minus 2 equals 0. So then my denominator is x equals 2. The line, I'm sorry, my vertical asymptote is the line x equals 2. Now, some of you might be like, Mr. Ellis, since I canceled something out, doesn't that make a hole? Doesn't it make a removable discontinuity? It absolutely does. However, we're not going to test it tomorrow, so I'm not going to take time because I'm trying to keep this video short. Okay? But you absolutely should remember, since I canceled something out, a hole is technically created. Alright? But we're just going to go over we're just going to use the two things we found to graph. So we found that y equaled 1, so that puts a horizontal asymptote at y equaling 1. Okay, I know my handwriting is just absolutely beautiful. And then a vertical asymptote at x equals 2. Okay. And now I can graph. And we just graph in the top right and the bottom left. Unless, of course, there's some reason, like a reflection, that I wouldn't graph it there. Okay? I'm sorry I'm so bad at drawing there. Okay? So, even though this isn't a question, I'm going to take a quick moment to go over it. The domain for this guy would simply be from negative infinity to 2, and then parenthesis, open a new parenthesis for the second side, from 2 to infinity. You don't have to do this. I know I didn't ask it. I just kind of wanted to quickly review it. And the range would be from negative infinity to 1, and then 1 to infinity. Okay? Alright guys, I'm sorry I couldn't make it out there 8th period. I get to go see my wife, I get to go with my wife to our sonogram to see our child, so I'm really excited about that. Guys, please send me a reminder if you have a question. Let me know if something's not making sense. Please do not come tomorrow and be like, oh, well, I didn't see you, so I didn't ask any questions, okay? I'll be in at about 8 o'clock in the morning tomorrow, so feel free to come in if you have any questions. Alright, thanks. Have a great day.